It's branch creeper has start. Today we are going to learn about a scalar and vector. This is part 1 video. In this video we will cover a scalar, vectors, tensor and other type of vectors. So let's start. So what is a scalar and what is vector? A scalar quantity has only magnitude. A scalar is a quantity as we have learned in the first video, that is in units and measurements, that units quantity units is used to measure the quantity. So here the a scalar is a quantity which has only magnitude, and if we were talking about the vector quantity, so then it is a quantity which has both magnitude and direction. So in scalar quantities, examples are length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work, power, etc. And in vector quantity, uh, some example of vector quantities are displacement. It has both magnitude and direction. Direction, velocity, acceleration, momentum, force, lift, drag, thrust, weight. And these all have units. So now vectors can be mainly classified into following two types. That is polar vector and axial vector. The polar vector, these vectors have a straight point or a point of applications such as force, and the axial vectors represent rotational effect and act along the axial axis of rotation in accordance with the right hand screw rule. This right hand screw rule we have also studied in the physics chapter 1. So, sorry, physics chapter 1 or in electromagnetism and electricity. So, this example of axial vectors are torque, angular momentum, etc. Now, what are tensor quantity? Tensor quantities are those physical quantities which have different values in different direction at the same point. Uh, Here we have to understand the difference between the vector and the tensor quantity. Vector quantity do have direction, but at the same time it has only a specific direction and a specific magnitude. But tensor do not have. Tensor may have both magnitude and direction of different at the same specific time period. So example of the tensors are moment of inertia, radius of gyration, modulus elasticity, pressure, stress, conductivity, resistivity, refractive index, wave velocity, density, etc., which we have studied in our first video of units and measurements. Then we have learned about their fundamental units, dimensional formulas, etc. So these are the examples of the tensors. Magnitude of, as I have said earlier, magnitude of torque is, tensor is not unique. It can be uh, different in different direction at the same time. Other type of vectors are equal vector. Number one, equal vector. So these are the vector which have same magnitude and have same direction. So here it should be noted that a vector having same magnitude, but if the direction is different, likewise if I consider number vector a this and vector in this direction, so these have equal magnitude, but they are not equal. They will call be negative of each other. We will study later here the negative vector. But things to be noted is that though they have same magnitude, let's consider it is of 1 mm, 1 mm, and this is also of 1 mm, but as their direction are different, so these are not the equal vector. Now negative vector, two negative vectors, the two vector of equal magnitude but have opposite direction are called negative vector. So basically negative vector is represented by minus of a, and here we can see that a is in right direction, and B is in another opposite, minus A is in opposite direction, but they have same magnitude. Let's assume that both are of both are of 1 mm, but as their direction are different, so they are not equal, but they are negative vectors of each other. Now zero vector or null vector. A vector whose magnitude is 0 is known as 0, or null vector is direction is not defined, it is denoted by 0. So basically zero vector is, we can consider a point as the zero vector, and we can only measure its direction is cannot be defined, because for a point which direction we can consider we can consider not any direction for a point, because point is simplest measurement. After point we comes to line, and after lines we come to 2 degree figure, that is point is 0 degree, line will be one, line is 1 degree, and rectangle, squares, etc., circle 2 degree in 2 dimension. So and 3 dimension is cube. So basically what we cannot define the direction of 0 dimension object, which is only just a point. So next, now unit vector, a vector having unit magnitude is called a unit magnitude. Unit vector means it has specified the direction, it has specified the particular direction, but its magnitude is 1 unit. Its magnitude is 1 unit. So this is a unit vector. For example, if we consider to find the unit vector, this formula representation of unit vector is by we use unit vector by using cap on it. So later we will study how to find the unit vector of a given vector. Now first let's think what is a unit vector. Is unitless and dimensionless vector and represent direction. Dimensionless vector and represent direction only, because uh, it it has no unit and it only represented direction. It can be only used to represent direction. And on the similar concept based, we study the orthogonal vector units, that is x cap, xi, x cap, y cap, x cap, y cap, and z cap, and we can also represent it with I cap, j cap, and k cap. So basically, let's state its definition. The unit vectors along the direction of the orthogonal axis. What are orthogonal axes? X, Y, and Z. Orthogonal axis means the axes which are perpendicular to each other. So only X, Y, and Z axis, which we now till now we know is that X, Y, and Z axis, which are perpendicular to each other. Um, so they are represented by I. It's don't consider it negative. I have used this hyphen to separate from the statement. So this is I cap. X is X is I cap, Y is J cap, and Z is represented by K cap. Basically here it is already written. See, I K cap, J cap, and I cap. Now co-initial vector, as from the name we can identify that it means it have the same initial point. So vectors having common initial point are called co-initial vector. As we can here see that both A vector and B vector have the same initial point, that is origin. Now collinear vector, vector having equal or unequal magnitude but acting along the same or parallel lines are called collinear vector. So basically it's means it does not depend upon the that its magnitude and direction. It does not depend upon the magnitude, whether the magnitude will be equal or unequal. It's have no effect, but only the things should be that it should be in the parallel lines. Here you can see that parallel lines are called collinear vector. Its direction should be parallel. Mm, Now coplanar vector, vectors acting in the same plane are called coplanar vector. Very basic thing, coplanar. We have read about the plane, that is xy plane, yz plane. So if we consider this in x and this to be y and this to be x, then the vector in this plane, two vector in this plane will be coplanar vector. Now localized vector, as we can identify it from the name, or we can guess it from the name, that localized vector it should have a fixed location. So a vector whose initial point is fixed is called localized vector. For example, here in first case co-initial vector, we have seen that it's 0 is the fixed origin of this both vector A vector and B vector. So 0 to A vector is a localized vector, and B vector is also localized vector because their origin are fixed. Now opposite of that is non-localized vector, which is do not have fixed point, is called a localized vector, and its other name is free vector because its position is free. Now position vector, a vector which gives the position of an object with reference to the origin of a coordinate system is called position vector. So basically it is represented by the symbol r, and we forgot one thing, that is not only r, it should be represented by r cap, because r vector, and for vector we use the notation this, or we use the bold letter. So this is the r vector. We study it with by pronouncing r vector. So position vector gives the position of an object, and it position vector always consider with a difference to the always take the reference of the origin to tell the position of an object, as we have studied in coordinate system, that like pointing 4 comma 4 on the coordinate system, xy plane, and 3 comma 2 4 comma 6. So these are the bus we can say that from 0 comma 0 to 4 comma 6, or 4 comma 6, 4 minus 0 I cap, and plus 6 minus 0 k cap is the position vector of 4.6 4 comma 6 in the coordinate system. So we are going to see its example. So here you can see that the b vector position of b vector is 0 comma 0, and here we have it is representing the position of b vector, and this here the arrow is representing position of a vector. Now last to this last topic, that is a displacement vector. The vector which tell how much an object how much and in which direction an object has changed its position in a given interval of time is called displacement vector. So let's assume this was our initial, this was our initial position of the this was our initial position of the vector, this was our initial position of the vector. Now it has changed to b vector position. So this displacement which we have so this displacement is called displacement vector, and it is represented by delta r. Now another than the displacement vector is a straight line joining the two initial and the final position, and does not depend upon the path uh, does not depend on the actual path undertaken by the object between the two initial point. Means that let's assume this is x-axis, this is y-axis, and our initial vector was here, and now it's covering the length like these. It has reached the point here, this point. So this is new point. So our displacement vector will does not depend on our displacement vector will not depend on this path. It will only say that your displacement is this, from this point to this point. Check it, I am highlighting it. Now from this point to this point, direct linkage. It was I was there a straight line, direct linkage. See this. So that's all. Thank you. We'll meet with part 2 very soon. Thank you very much.